Alright everybody, welcome to Physics 20. Today we're just going to look at introduction to the course, and we're going to do some math and basic science review so we can kind of get consistent when we're doing some physics calculations. Before we get to that, I just got a little bit of an intro. So what is physics all about? Basically, if there wasn't physics in our world, it'd be like we live in the Bugs Bunny cartoon. So you guys probably seen this cartoon where the coyote goes running off a cliff, kind of runs straight out, stops for a second, holds up the little help sign, and then falls straight down. So cartoons are famous for showing inappropriate physics. So what we're going to be doing is we're going to be looking at sort of what our world is like with physics involved and how it works and how we can predict certain things. A good example of what we're going to be learning in Physics 20 can basically be described in one launch of our space shuttle. All the different parts of the space shuttle covers all different kinds of things going on in physics, and most of those topics we'll be covering in this course. So we'll just kind of go through a quick scenario here just to sort of show you what I'm talking about. So our space shuttle, when it first launches, to leave the ground, it has to have more thrust force to get it to lift off the ground to overcome gravity. So we got a bunch of forces going on at the ground level. When it launches, it's going at such a huge speed because it gets faster and faster. So you can see over here as it launches, we're getting bigger speed or velocity because it's accelerating, and the reason it's doing that is the thrusters are pushing lots of force. We have less gravity to overcome, less mass as the fuel burns off. So the thing gets going faster and faster. And a cool thing with that is as we hit a certain speed, we get to a certain speed, we'll start breaking sound barriers and things like that. Energy gets burnt off. As the fuel gets burnt, we can start giving off energy as heat. And eventually, once that space shuttle gets out of our atmosphere, the astronauts will appear weightless. You see them on TV where they look like they're floating around. What we're going to learn about is that they're actually not really weightless, but it's just an apparent weightless, and we'll figure out how that works. And eventually, once they're up in orbit, the space shuttle will go in circular motion around the Earth, and it'll just orbit until they're done what they got to do, and then they got to tackle gravity and reverse the process and come all the way back down again. So our physics course, we're going to be looking at all these kind of things. Our first unit, we're going to be dealing with motion. We're going to be looking at velocity and acceleration and things like that. And then we'll get into forces and circular motion and energy and those kind of things towards the end of the course. So it's just a pretty good little preview kind of to get your mind wrapped around what we'll be looking at in this course. And it's probably my favorite course ever to teach. There's lots of cool things. We'll be doing some labs along the way to get our hands on some of this stuff, and it should be good. Today what we're going to do is I just want to make sure everybody's on the same page and can be able to do some calculations consistently, because in physics, because you're going to be using your calculator lots and doing lots of math calculations, we need to make sure we're consistent and clear on how to do everything the same. The first thing we're going to look at today is being able to do metric conversions from one unit to the other. In physics, we have all kinds of units, we have all kinds of prefixes, so instead of kilograms, it might be grams. Instead of meters, it might be kilometers, or it might be millimeters, or picometers, or whatever. So there's all different kind of conversions that you have to be able to do. And the trick will be to make sure you got the units in the right form.
Mr. Crook, please call the office.
Before you do any kind of calculation. So on your formula sheet, you can see in the bottom right corner, they give you a little chart that shows all of the metric prefixes. So we'll kind of go through a few of those first. So if you look on your sheet, you can see centimeters. On the sheet, they write that as 10 to the negative 2. So what that means is they're saying is 1 centimeter is 10 to the negative 2 meters. So how that comes in handy is you can kind of do it one of two ways. On your calculator, you could just put in 85600 times 10 to the negative 2, hit equals, and it'll give you an answer of 856. Or you might have learned over the years to be able to convert, you can sort of always just move the decimal places. So if we have 85,600 centimeters, and if centimeters is to the negative 2, that means we're going to move our decimal place 2 spots smaller. We're going to make it 2 spots to the left, so that would be 856. And the same thing would work for the next example. You can see we got 257,000 milligrams, and we want to get that in grams. So if you look on your chart, milligrams is to the negative 3. So that means we're going to move the decimal over 3 spots. So our answer for this one should be 257. Okay, doesn't matter what the units are, just kind of use your chart to help you out if you're stuck. You can see gigahertz, so 0.5 gigahertz. You guys that are into computers, you would have heard things like gigs and terabytes and things like that. Those are all just metric prefixes. So on your chart, you can see gigahertz is 10 to the 9. So that actually means that it's trillion. So a gig is like 9 more spots. So because it's positive 9, instead of moving to the left this time, we're actually going to be moving to the right. So we're going to add on 9 decimal places. So you'd have 0.5, we're going to move that over 9 spots. So you'd actually have 5 and then 8 more zeros. 1, 2, 3, 4, 5, 6, 7, 8. So 0.5 gigahertz is actually 5 with 8 zeros hertz. So a gig is pretty big. You can see on your sheet a terabyte is actually bigger yet. It's 10 to the 12. So if you buy a new computer with a terabyte of memory, that means you actually have 10 to the 12 bytes. So it's a massive amount of storage ability. Okay, let's do a couple more. 0.25 liters to milliliters. So you can see this time it's sort of backwards. Instead of going from milliliters to liters, we're going the other way around. So this way you got to be a little bit careful. It's milliliters. Milli is negative 3. But we're going the other way around. So because we're going smaller, we're going to actually be going 3 to the right. We're going to move 3 to the right, so we'd actually have 250. So 0.25 liters is 250 milliliters. Okay, and let's do one more. 0.0054 megameters to meters. So mega is to the 6. So that means we're going to move it to the right 6 spots. So there's 4, so we'd have to add on 2 more zeros. So 500 or 5,450 meters. Okay, so we'll do a few more. I'll give you some questions like this as an assignment so you can practice, but it's just basically using the metric system and be able to convert one way or the other. So either adding on decimal places if you're going from a big one to a small one, or if you're going small to big, then you're going to be removing decimal places. The other conversions that we're going to do quite a bit in physics is converting time. And time is a little bit tricky. You got to be careful because it's not a metric system. Time is totally separate. The good news is we're not going to get questions where we're going to be dealing with feet and inches and things like that. Physics is all metric, so we stick with just metric numbers. But time is one of the ones that's totally different. So what you just have to remember is sort of what are the standards for time. And the key thing is you have 60 seconds equals 1 minute, right? And then there's 60 minutes in 1 hour. There's 24 hours in 1 day, 7 days in a week, 365 days in a year, that type of thing. So you're always going to be converting sort of time back and forth. What you got to just basically remember is the 60, 24 hours, weeks, days in a year, that type of thing. You're going to be able to convert. So this first one I've got here is 1.5 days. We want to figure out how many hours that is. So we have days to hours. There's 24 hours in a day. So we'd actually, for this one, you'd have to go 1.5 times 24 on your calculator. So 1.5 times 24 is 36. Okay, so 1.5 days equals 36 hours. Let's do this one, 0.0045 years to hours. So on your calculator, put in 0.0045. That's years. Let's change it to days first. Let's divide that by 365. That'll give you how many days? So it's 1.23 to the negative 6, so it's scientific notation. We'll get to that in a bit. And So that's in days, but then we still got divided again by 24 hours to get hours. So we actually get 5.1 times 10 to the negative 8 hours. Okay, so your calculator shows 5.1 e negative 8. So the e just means scientific notation times 10. We'll get to that in a minute. Okay, let's do another one. 560,000 seconds to minutes. So we're getting bigger, so we're going to divide by 60. So that gives us 9,333 minutes. Okay, let's do another big one. So we're going to go years to seconds. So this one's going to be quite long. So we're going to go 1.3 years. Let's times that by 365 days. That'll give us days. Then we're going to times it by 24 hours to give us hours. Then we're going to times it by 60 to get minutes. Then times it by 60 again to get seconds. So 1.3 years, when you do all that on your calculator, you get 40996,800. So you get quite a few numbers, and that's in seconds. And the odd time, we will actually get a time conversion that goes from metric. It's in metric, and we're using metric conversion. So this one, you'd have 0.00032 nanoseconds, and we want that to be in regular seconds. So we go back to our chart. A nanosecond is to the negative 9. So what we're going to do is we're going to move the decimal places over 9 spots. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd actually have 32,000 seconds. And I did that backwards. I converted that in the other way around. So instead of me redoing the question, let's just change it. So let's say the original was in seconds, and we want it to be in nanoseconds. Okay, everybody clear with that? I kind of messed up. So I went from small to big, and I made the number bigger where it should have actually been smaller. So let's switch it around. So if that was originally in seconds, we want it to nanoseconds, we would add on 9 decimal places, and that's it. So that's sort of the first topic, is be able to do metric conversions. You saw in the one question we had to use scientific notation because the number was really big or really small, and that's all scientific notation gets used for, is to help us convert numbers so that they're easier to work with. Instead of having a ton of zeros at the beginning or at the end, we just make things a little bit easier. So just a couple quick examples to remember how that works. So this first one, 101,250,000. To make it in scientific notation, remember you always put the decimal after the first digit. So you'd have 1.25, then we don't worry about the zeros. We rate it as 1.25 times 10 to the 2 for 6 decimal places, right? From the decimal to the end, we moved it over 6 spots. Okay, so do the same thing for this one. Go from the end to one spot after the first number. So we'd have 6.59. There's 9 numbers there, so we'd have times 10 to the 9. Okay. Same thing works when you go the other way. Go from the decimal, go to the after the first non-zero digit. So we'd write this one as 3.5, and we went 1, 2, 3, 4, 5 spots to the right. So it's the same thing, except we write it with a negative. So positive exponents for big numbers, negative exponents for the really small numbers. And do the same thing here. We want to put the decimal after the first 6. So we'd have 6.02. And we're going to get 2, 4, 6, 8 decimals to move over. And that's it. So that's converting from one way to the other. The other one is to go, when you have it in scientific notation, to go back. So remember, your calculator quite often uses E or EE. Depends on what brand of calculator. So this one just basically means 1.25 times 10 to the 4. So in this case, to make it regular numbers, we're just going to move the decimal place over 4 spots. We'd have 12500. Okay, and then the other one, the same thing. If we have 5.4 to the negative 3, we're going to move the decimal 3 spots to the left this time. So you'd have 0.0054. And just make sure when you kind of do it, you make sure your decimals are right. So here we went from the 5.4 where it was, we moved it 3 to the left. Where this top one, we started at 1.25 and then we went 4 to the right. So Those are usually pretty easy to be able to convert back and forth, but just kind of be aware that your calculators quite often shows it as EE. And to type it in, if you're going to type something in scientific notation, you just do it just like that. You go 1.25, go find your EE button on your calculator, and that's it. So I'm just looking on my calculator if I can find it. There it is. Yeah. So you go 1.25 second cal, like the second feature or shift, EE, and then you put in the 4. Okay. One more thing that we gotta do or worry about for today is we gotta figure out how to do significant digits. So significant digits are just helping us to be able to round things properly. So when we're doing significant digits, first of all, you gotta know how to count significant digits. And there's a simple rule that we basically stick with, and that is we count all digits, and we just gotta be very careful about the zeros. So if there's zeros to the right of a normal number, we do count those. If the zeros are to the left, we ignore them. So for example, you can see with this first one, we have 2300 because they're to the right. All of those digits count. We have 4 sig digs. If you look at this next one, we have 0000 in the front. Because those are to the left, we don't count those. So we're only going to worry about the 2 regular digits, so we have 2 significant digits. Here we have a 0 in the middle. That's fine, so we have 3 digits. So the zeros do count if they're in the middle. And once again, here we got some zeros in the middle, so all of those count, so we end up with 5. So when you're doing significant digits, just basically the trick to remember is ignore the zeros to the front. Those aren't going to be important. You only worry about the zeros to the right or in the middle. And when we're doing physics calculations, the general rule is when you're doing calculations, you want to keep all digits and decimal places in your calculation, and then you just worry about rounding at the very end. So any kind of formula you're going to be using, you're going to be plugging in numbers in your calculator, just type everything in, keep everything as accurate as possible, all those decimal places, and then at the very end you just round it appropriately. And the rule is we round it to the least number of sig digs on the numbers that we're using in our calculation. So given to the question, so you'll get questions, things like Bob is going to be driving his car, he starts with a speed of 4.5 kilometers per hour, he's going to increase his speed to 8.7 kilometers per hour, and he does that over 2.45 minutes. What's his acceleration? So you're going to use all those numbers in the question, plug it into a formula, and then figure out your answer. So for now, we're not going to worry about the formula so much. I just want you to kind of get the idea of how you would round these things off. So this first question, let's do this one. So on your calculator, type in 7200 times 5.6 times 0.002. So we get an answer of 80.64 when you do that on your calculator. So the question is, how should we write that, or how should we round it appropriately? So use rounding rules that you normally would do, and then we use the sig dig rules to help us figure it out. So the 7200, we have 4 sig digs, 5.6 we have 2, and 0.002 we only have 1, right? Remember that only the 2 counts. So we have to then write this as 1 sig dig. So to use 1 digit, how do we round 80.6 to only 1 number? We can't really do that, so we just use the 8, right? 8 is our first number. Our second digit is a 0, so we don't have to round it up to a 9, we just leave it as an 8. But then we would write it as scientific notation, so you'd have 8 times 10, we move the decimal over 1 spot. So you'd say 8 times 10 to the 1 would be our final correct answer in scientific notation to the right number of sig digs. So when you're doing significant digits in scientific notation, we only worry about the front number for the sig digs, not the times 10 part. Okay, let's do a couple more quickly. So this next one we have 3200 divided by 4.23. Do that one on your calculator, you get 756.5. And how many digits do we need to round it to? The first one has 4, the second one has 3, the least number is 3. So we'll change ours to just 3 digits, so we want to use the first 3. So 756 is good. Remember, always go to the one past. So in this case, we have a 0.5 because it's 5 or bigger. That's then going to round our digits up. So this one, our correct answer should be 757. Okay, one more. 3.14 times 4.5. We get 14.13. 3 digits there, we got 2 digits there, so 2 is going to be the right answer. So only want 2. So in this case it's just 14 because it's 0.1. We don't need to round up, we just leave it as 14. And one more, 1.65 times 9.81. Let's hit that answer first, then we're going to subtract 2.5 times 6.25 times 0.05. So for this last one we get 15.4. And how many digits we need to round it to? We got 3 there, 2, 3, and just 1. So this is kind of like our first one. Our least number is 1. So we're going to round it to just 1. So we'd have just the 1 for the 15, but because it's 15, it gets rounded up to 2. So you'd round it to 2, and then we got to move the decimal over 1 spot. So that means we got to change it back to scientific notation once again. And that's it. So quick review for today. We're looking at changing metric prefixes back and forth, so going from millimeters to kilometers and things like that. Being able to do significant digits properly and scientific notation, and then rounding your calculations. So there'll be a worksheet to try some of this stuff out on, and then tomorrow we'll get on to start of the course. See you later.